Alright, let's have a look at problem 2321, maximum score of spliced array. So for this problem, we're going to share a solution based on Kadane's algorithm. So first I'll go through the statement of the problem, and then we will explain the idea and build the intuition. Finally, we share the solution and code. First, let's look at the statement. So we are given two zero-indexed integer arrays, nums1 and nums2. They have the same length m. So we can choose two integers, left and right, and swap the corresponding pieces of the two arrays, starting from left and ending at right. So for example, nums1 and nums2 here. So we choose left index to be 1 and right index to be 2. Then we can swap the 2, 3 with the 12 and 13 in these two arrays. So we get another two arrays, that is this one and this one. So the first, the positions 1 and 2 change to be 12 and 13 in the first array, and the positions at 1 and 2 change to be 3 in the second array. So we may choose to apply the mentioned operation VAS or not do anything. So here, this paragraph defines what's a score of the two arrays. So the score of the arrays is the maximum of sum of these arrays. So the question requires to return the maximum possible score. So here it specifies a subarray is a continuous sequence of elements. So with that said, let's look at these examples. So in example 1, so the return is 210. So this is a replace. We replace a 19 with 16. In other words, we choose left and right to be 1. So in example 2, so we replace the last two elements. So we get a result 220. So in example 3, so all the elements in nums1 is greater or equal than the elements in nums2. So we return the sum of nums1, that is 7 plus 11 plus 13. That is 31. So with that said, let's look at the constraint of the problem. So the length can be up to 10 to the power out of fifth, and the last constraint is about the element range in the two arrays. So with that said, let's look at the method and the idea behind. So the method we're going to use is essentially a dynamic programming method. So here we are going to use the Kadane method or algorithm. So here we want to make several observations. So that's actually establish the intuition or main procedure of the problem. So we assume that nums1 has sum s1 and nums2 has sum s2 at the very beginning. So the first observation is from example 3. So if each number in one array is no less than or respectively no more than the corresponding number in the second array, then we are going to return the maximum of the two sums, s1 and s2. So this is the one case. And the second observation is that if not in the first case, we are going to consider difference array. For example, we consider the difference array of nums2 minus nums1. We get this auxiliary array. So then we just need to find the subarrays with the most largest sum and the smallest sum and do the switch. So for example, if the maximum subarray for the difference array is m, it means that if we switch the corresponding part, then s1 going to be increased by this m, and s2 going to be decreased by this m. So we are going to consider return max of s1 plus m, capital M, and S2 minus this m. Similarly, if the minimal subarray sum for the difference array is little m, we shall consider return max of S1 plus m and S2 minus m. Notice again, still plus and minus, S1 plus and S2 minus, but this m can be negative, right? So that's the point. But then, after we transforming this question, the things are very simple. So how do we get the maximum subarray sum or minimal subarray sum? So that's nothing but the standard Kadane algorithm, right? The original Kadane algorithm is concerned with the maximal subarray sum, but we just make some modifications, we get the minimal subarray sum, right? So that's the intuition and idea behind. So let's look at one example. For example, we have nums1 and nums2 is given here. So S1 is 135 and S2 is 190. Then we consider the nums2 minus nums1. The difference array is 30, 0, negative 40, and 85, negative 20, and 0. Then the maximum subarray is the maximum sum subarray is I guess is 85. So here let me write 85. So then the minimum sum subarray is negative 40. So basically we're going to return S1 plus 85, S2 minus 85, and S1 plus negative 40, and S2 minus negative 40. So in the first case, S1 plus 85 is going to be 220, and S2 minus 25 we're going to be 105. Similarly, S2 minus 40, S1 minus 40 is 95, and S2 plus 40, that is minus negative 40, is 230. So the result is 230. So that's basically the result and the idea. So with that said, I guess we are ready to write the code. So for that purpose, let's first make some preparation. I'll first track the information for the sum. So that is sum of nums1 and sum of nums2. And also, I'm going to consider the difference string. So y minus x for y and x in zip, nums2 and nums1. Here I'm using nums2 minus nums1. So first I want to do a check. So it corresponding to example 3. So if all the items, so item greater or equal than 0 for atom in aux, or so they are less or equal than 0. This corresponds to the first observation. So I'm going to return the max of S1 or S2. So this is the checking for the special case. So number 2 basically is hyperfunctions. Hyperfunctions, we're going to compute the maximum subarray sum and minimal subarray sum. So here I'm going to write 2 functions. One is Kadane maximum. So given an array, I'm going to return the maximum subarray sum. So this is simple. It just directly writes according to Kadane's algorithm. So aux 0. Then we are going to iterate for I in range. So we are starting from 1 and up to length of this aux. Now we are computing the maximum, right? So we are going to check if current is less or equal than 0. We are going to set current equals aux I. So the current means that the maximum sum ending at index I, right? Otherwise, I'm going to increment current by aux_i, right? So then I'm going to reset the result to be maximum of result and the current. So let's check the logic. So we do the iteration. If the previous current is less or equal than 0, so I'm going to set the current to be aux_i, and if it's greater than 0, I would increment the current by plus this current number, aux_i. Then I will compare the maximum, and then after this for loop, I'm going to return this result. So with same idea, I'm going to write another one called Kadane minimum. I'm trying to find the minimum subarray sum. So here again, I'm going to initialize like this, but change the logic a little bit. For I in range 1 up to length aux. So I'm going to check if current is greater or equal than 0, because currently I'm trying to find the minimum. So if current is greater or equal than 0, I'm going to set the current to be aux_i. And then otherwise, if it's less than 0, I'm going to increment the current by aux_i. So the current means the minimum subarray sum ending at this index. So after this, I'm going to reset. I'm going to compute the minimum of result and the current. And finally, I return the result. So we can test for this case after we finish all the code. So now, first let's do the maximum result. So find the maximum subarray sum, that is Kadane maximum of this aux, and then we do the minimum of Kadane minimum aux. Then based on the second idea, what we are going to do is that we return maximum of S1 plus result maximum, S2 minus result maximum, and S1 plus result mean, S2 minus result mean. Right. So that's the return. So let's first check for several examples and then do the generic case check. Yeah, it passes this specific example. So let's output this result max and result mean, just make a comparison with our example. So result max, result mean. So the maximum subarray result is 85 and the minimum is -40, corresponding to here 85 and -40. So with that checked, let's comment this print out, and then let's check another examples. For example, here let's do the check. It passes the first example, and let's do the second example. It passes the second example. Let's look at the third one, which is sort of the edge case we treated in the code. So yeah, it passes this one. I guess it's a good time to try all the cases. Let's submit. Alright, it's not bad. So actually, in my first try, I just considered the minimal, Kadane minimal or Kadane max. We need to consider both. I guess that's the point of the problem. So overall, we transformed this problem to be a dynamic programming problem using Kadane's method by considering the difference array if necessary. Then we write the Kadane max and the Kadane min, and then we return the maximum of the possible choices. I guess that's about it for this problem. Thank you very much.